everyone. Many thanks for joining this, the fifth and final webinar in the current series on floods and drought management. My name's Gareth Lloyd and I work at the UNEP-DHI partnership. It's my job to be your facilitator of the webinar today, and with me is Maija Bertule, also of UNEP-DHI, who is providing the technical support. This webinar series is a collaboration involving a number of partners, including GEF, UN Environment, IWA and DHI, and along the way we've had other valued partners making additional contributions. The overall aim of the series is to give an insight into approaches for addressing floods and drought management issues, and in the series we've been hearing all about the applications of tools and methods, particularly innovative ones, as well as experiences in applying them at different scales. In a moment I'll get to the agenda, but just before then, one second. Yes, I'd like to tell you a little bit about the story behind this webinar series. This webinar series has been an offshoot of a global environment facility project, which is all about developing and disseminating cutting-edge flood and drought management tools that are of generic applicability. And what's been developed by this project is based on specific input from river basin stakeholders in 3 diverse geographies, as well as other additional experts. And following development and testing, the tools are being made freely available online with instructions and other assistance provided for their application. So I won't go into lots of details about that, but if you'd like to learn more about the project, please check out this link after we're done here, and kindly note not to use the www prefix. Well, today we've covered quite a few topics, and amongst those have been the use of satellite data for drought and flood management, new techniques for improved preparedness and adaptation to floods and drought. We've also looked at experiences in drought warning and assessment using African cases, and last time around we went into water safety planning, both in theory and in practice. Today we're very pleased to have 2 experts with us who are new to the webinar series and will be sharing their knowledge and experiences on basin planning. As most, if not all of you know, of course, basin planning in simplistic terms is about figuring out how much water you have and what condition it is, who gets how much and when, and of course who pays for what and how much they pay. The reality of basin planning is, of course, that calculating and, of course, agreeing on all this, these kind of issues, especially in rapidly evolving situations or perhaps situations with scarce resources, that's a real art requiring good data and, of course, stakeholder buy-in, amongst other things. So today we have my very good DHI colleagues who probably have between them a combined experience of 50 years or so. No pressure there on you then, Børge and Silvia. But they're going to be sharing their current experiences working on some ongoing projects. We have Børge, who's going to be talking about experiences in using decision support tools in the Shire Basin in Malawi. And we have Silvia, who's been doing some very interesting work on innovative applications for stakeholder-driven planning, and you know, how by using a certain type of application in a certain way, you encourage greater engagement from some of the key stakeholders, which of course is one weakness in basin management practice. Each presentation is probably going to take about somewhere between 15-20 minutes, and the plan is to allow for a question or so immediately after each, just to break things up. We'll also be allowing some space at the end for additional questions, so if you have any, please let us know. And I'm not sure if you can see it, but On your screen you should have a panel in front of you. If you can't see the panel, you probably need to click on that orange arrow and expand, but there's a space in there for you to write and submit your questions to us, so please feel free to make very good use of that. A small request from my side is that you try to keep your questions as brief and to the point as possible, so that we can quickly understand and direct them to the best person to respond. If you have an idea of who specifically you would like to respond, whether it's Sylvia, myself, or Børge, then please feel free to let me know when you write the question. I also need to remember to tell you that all presentation slides and webinar recordings from this series, including this one, are already publicly available on YouTube or will be in the next few days, and you can access those through the UNEP-DHI.org website. Without further ado, I think I would like to ask Maija to pass the presentation over to Børge so he can begin. Børge, if you can unmute your microphone and pull up your slides, then yeah, we can see your slides. You're now in presentation mode. If you can unmute your mic.
Thank you, Garrett.
You're good to go. Thanks.
Thanks. Yeah, the theme of my talk is about implementation and use of the DSS-oriented tools in basin planning. And the example that I will show is from an ongoing project with the title Development and Strategic Plan for the Development and Management of the Shire River. It's undertaken by NERAS in collaboration with DHI and GUA Consult. And it is done under the Shira River Basin Management Project in Malawi, funded by the World Bank. It's actually a long-term program with a phase 1 ending early in 2018, and it will be followed up by subsequent phases. The outline of my presentation will be a brief introduction to the Shira River Basin and some of the key issues, a brief introduction to the planning approach that we have taken, and presentation of the tools of the planning DSS and example of use. But let me first introduce you to the basin. Malawi is a relatively small country in southern Africa, surrounded by Mozambique, Zambia, and Tanzania. And the Lake Malawi Shira hydrological system represents Malawi's single most important natural resource system. The Shira itself originates at the bottom of the Lake Malawi, and it runs through the southern part of Malawi to the Zambezi River. It provides a number of productive purposes, including hydropower, agriculture, fisheries, transport, tourism, and urban and rural water supply, and in addition also some environmental functions. The Shira River is joined by a number of smaller streams, but also a larger rivers like the Ru that is running on the border of the Mozambique and Malawi. The basin, Shira Basin area here, which is, you can call it a planning unit, is around 20,000 square kilometers. It runs generally in a very gentle and flat gradient, but in the middle section there is a steeper sections where a large number of hydropower schemes is located. In the lower part there is substantial wetlands which support extensive dry season agriculture and also high level biodiversity and fisheries. There is a high population density in the Shira Basin, and that has led to significant human pressure on the environment and degradation of the Shira Basin's natural resource base. The growing population expands land area under cultivation and exploits forest and woodlands for firewood and charcoal production. So there has been undergoing a large deforestation, and there is a big threat from soil erosion and sedimentation to the environment. This here shows the sub-basins that the planning has been going on within the Shira Basin. The threats to development has been listed here, and you can see there's the high population growth, there's poor basic education, there's the reliance on smallholder agriculture, there's the high dependence on biomass for energy, which causes this deforestation, and there's basically a very limited basis for economic growth, and there's a lack of widespread electricity distribution to households. In addition to these, there are also the adverse impacts of climate change. Climate change has impact on the basin itself, but it has also impact on the Lake Malawi, which is feeding the Shira Basin. In a workshop in June 2016 for key holders and officials, the team leader used the opportunity to get the participants to assess in broad terms the present status of integrated water resource management in Malawi. The purpose was to identify areas where non-structural interventions, in contrast to structural interventions such as hydropower schemes, reservoirs, irrigation and so on, would benefit in the management of water resources in Malawi. Each participant was asked to rate Malawi's status with respect to a number of attributes that you see here under 4 different headings. And the number that was, they could select between poor, fair, good and excellent. And the number that you see on this table is how many votes each of these for each attribute on each rating. So you can see there was 12 attendants to this workshop. And what you notice here is that there was quite a big agreement that the major difficulties in water resource management is lack of knowledge, which was rated poor from most of the participants. And lack of knowledge arises from lack of information on water quantity, on water quality, but also on different lack of different analytical models and so on. Basically, also there was a rating of fair for all the other institutional framework, the community involvement and the integration. The basin plan for the Shira Basin, that will address all these, but it's important to notice there that the use of DSS seems to be an important part of the future water resource management. The structure of the plan, which is being developed right now, is that the approach is to make a situation analysis. This is normally done in different types of assessments, and that is followed then by defining a vision for the river basin, identify key areas that needs to be addressed, and the objectives that need to be achieved. And fourth, also the strategies recommended to setting what needs to be done in order to achieve the objectives. From that on, then there is the sectorial planning that examines the relevant sectors for water resources and land resource management. There are the important thematic areas like groundwater, surface water, water quality, soil erosion, and etc. And then there's also the climatic change planning. With an investment plan in place, then it is important to assess and document the expected environmental impacts of the recommended investments through a strategic environmental assessment. It's also important to develop a dissemination plan for the water resource plan, and also to monitor and evaluate the implementation of the plan in the future. I'll just shortly show this slide here, which actually describes the vision that, as it has been defined by the Shire River Basin Management Program in consultance with key stakeholders. And it says that by 2035 we envisage prosperous families, green catchments, and healthy waterways in the Shire River Basin. The order of these three phrases is important, as people must come first. Even through environmental protection and enhancement is important. Because history shows that people in any country are not in a position to care very much about the environment until they achieve a certain standard of living. So the key areas in the plan is based on this vision is actually the three phrases that comes from the vision, but added also additional areas like robust institutions and planning, and reliable data and information, which are important for being able to do a water resource management in the future. The Shire River Basin Plan is being produced right now, and it will actually be presented in 12 volumes as listed in this. This project here will end later this year, and these plans here and volumes are now due for revision by or review by the client. Now I come to the DSS framework. And you can see that from this approach here that there will be a need for different types of tools. And the implementation has included tool development or use in terms of setting up an information and knowledge portal, and also creating simulation models and DSS tools and techniques. And there has been a second activity on technology transfer involving capacity building and training and subsequent installation. The planning DSS is used in two ways. It's very much used in the, you can say, the situation analysis reporting, where you collect, process, store, analyze, and share different types of data. And in that case, in that respect, it has mainly been the information system and the knowledge portal that has been very important, but also different types of mathematical models. The mathematical models and the DSS tools has then further been used in evaluating planning options and coming up with recommendations for the basin plan, as illustrated here in this slide. I'll just briefly present the information knowledge system and portal, and basically it consists of a database and then two different interfaces. One interface which is a Windows version, which is used by technical staff in the River Basin organization, and the second one is a web portal for dissemination and sharing of information with a wider audience. So that will be accessible for the stakeholders, consultants, and others that are working in the basin. The information and knowledge portal, that includes all sorts of spatial and temporal data that has been used in in the planning process. And that can be many different types of data, both records, but also different types of characteristics of different kind. It also contains publications that has been produced during the assignment. It makes links to other existing databases and websites. Actually, in this case here, there is an existing website which is called MASTAP that contains a lot of information for Malawi on spatial data. And then there will be there's access to different types of analytical tools, GIS tools, different types of models, and also the basin planning tool, as I will describe later. This here is just a snapshot or screen dump of the planning web portal as it is today, and it is located on this website. So it's currently hosted at DHI, but it will then be transferred to the client when the project is ending. This one here shows one of many different types of GIS maps that has been produced as part of the planning process. It also includes a large number of data from the monitoring stations, groundwater, surface water, water quality, and so on, which can be analyzed and looked at. And then it contains also different types of knowledge products, for instance, different types of reports and tools and so on, which can be downloaded and freely available. Now I'm coming to the planning tool. The planning tool was developed at this project here, and it has been designed such that it is easy to use, and which allows then the water resource practitioners, managers to configure and investigate different planning options, as well as add new intervention and investments without having to be trained in the simulation model. So we developed a simulation model for the Shire River Basin based on a mathematical model, and then we developed a planning interface which then the authorities we have used and the authorities used, and actually also stakeholders can use to look at different results. The simulation models has been developed such that it is quite generic in the way that it can adopt new interventions or investments, as we call them, without modifying in the model. So the concept here is simply to hide the complex modeling and analytical tools that is also used to analyze the outcome of the simulation models. And this obviates the need for users to have expertise in river-based modeling in order to successfully evaluate alternative planning options. So when the user is assessing this planning tool, it will open up the home page, and that is basically the landing page view when the application is starting. The main tabs of the application are shown on the top here, and there is only 3: planning options, investments, and strategies. For investments, you could also see interventions. So if we go to the planning options, then you get a new view here, and you can either view previous analysis, different planning options you have been running before. You can also add new planning options to it, and you can select different external scenarios to these planning options. So basically, you can view results from any planning options on which is based on indicators, as I will describe later on. You can compare different planning options in so-called basin scores to evaluate which one gives the best results, and then you can simulate a new planning options. The slide that you show here has a pop-up window with details for a specific planning options, where you can see there are different types of investments that you can click on, and you can select different external scenarios and then run the model. I'll just get back to, I'll just describe a little bit the external scenario approach. We have analyzed the Shira Basin for 3 different development storylines, scenarios you can say, A1B, A2 and B1, and they influence the Shira Basin and also the Lake Malawi in different ways. Then we have forecasted 3 different population growth, a low, a medium and a high, and population growth that will influence the amount of water that is needed for water supply. We have also, because the Shira Basin is the lower part of Malawi, we have also an external scenario on upstream development. We know that there is considerable upstream development of irrigation in Malawi, upstream of Lake Malawi. And these can be imposed in the model by different types of, different amounts of extractions, which will then influence the water level in Lake Malawi and the subsequent outflow from Lake Malawi. And finally, we have also put the environmental flow as an external scenario, but it's basically not an external, but it's just from a programming point of view, it's easy to select here. So there are different kinds of environmental flow requirements that you can thresholds that you can select. It should be mentioned here that the environmental flow protection has the top priority in the Malawian water resource legislation. So just to see the internal workflow of the planning tool is that one developed as part of the planning process a priority or a long list of different priority investments for irrigation, water supply, hydropower, dams, groundwater, and so on. In each of these investments, you will have the water requirements. You will have what type of crops it is producing. What are the costs of establishing the irrigation, but also what are the economic return when it is used. And that is then combined with the external scenarios to produce input time series to a simulation model, the basin model. And the basin model will then run for a certain time horizon. We have used a 30-year time series, and then it will come with output of flows, lake levels, runoff, groundwater output, but also how much water can be allocated to different water users. And these will then be processed into indicators, giving a very precise information about reliability of supplies, environmental supply, reliability of energy, economic benefit, groundwater sustainability if groundwater abstraction has been included as part of the planning. And finally, there will be different strategies which will produce weights that can then, depending on what development path that the authority wants to follow. It could be a water resource development path, or it could be an environmental sustainability path, and so on. And finally, that will then conclude in evaluation of both indicators and basin scores, so you can compare different planning options. This here is one output from the model where you actually look at different basin scores for different planning options. There has been 4 selected, and there has been used different strategies. You can see balanced, development focused, or environmental focused. This is also an output from the model, and it's just to illustrate that you can start to compare these different interventions where you combine different investments with different types of external scenarios, and then look at what are the reliability of the indicators. So the indicators could be reliability for overall irrigation, for water supply, energy production, and so on, and the net benefit in $1 million per year, and so on. And then one can start to compare these results and see which one provides an acceptable output.
Sorry to cut in. Just 2 minutes, please, if you could.
Yeah.
Thanks.
This here is illustrating that there was 20 interventions or investments that was proposed at a workshop, and you can see they have been divided into different categories or sectors, and the model was then used to rank these investments and find what are the best planning options to follow. If and there are both a combination of irrigation, but also water production, hydropower, and others. And actually, some of these investments, they are already on the drawing board. I think actually this concludes my presentation. In summary, I would say that there is a comprehensive basin plan for the Shire Basin that is in its very final stages of preparation. There has been a planning DSS framework developed comprising of information and knowledge portal, but also planning models and tools that has supported the strategic planning process. And then training of counterpart has been undertaken. Thank you very much.
And thank you to you as well, Børge. That was a really interesting presentation. I think it was great for setting the scene in terms of the challenges of putting, the theories of river basin planning into practice, and of course this more people-centered approach. A quick question for you before we move on, kind of expanding out a little from the local setting. The tools that are being made here, as you mentioned, they don't necessarily require advanced skills in river basin planning to be able to use them, or advanced programming skills. Do you see this as kind of the future of software development in this area? Is that the way it's going?
Yes, certainly I think so, and it's also important to stress that this planning process is not a one-off. It's actually, that will be a part of a ongoing integrated water resource management, and which needs, because this planning, the plan that will need to be revised from time to time, and it will also be such that these tools can then now be used by the Shira Basin organization to revise the plan by themselves. So I think this is very important, because the experience in the past has been that a lot of plans has been repeatedly done, but the output has mainly been reports and recommendations without any possibilities for the authorities actually to work on revisions themselves.
Okay, so it sounds like we're moving in some new and interesting times, and a break from the more traditional ways of the past. But many thanks for that. We're a little pressed for time. Don't run away, please, though. I can see we have a lot of good questions coming in. Maija, if you could pass over the presentation to Silvia. And Sylvia, I'll let you know when we can see your presentation and hear you. In the meantime, to the participants, please make extra good use of the question box. I can see there's some good ones coming in, and we'll make some time to pick up on a few more of those when we come back after Sylvia's presentation. So Sylvia, we can see, yes, your presentation looks good. We can't hear you yet.
Hello?
And now we hear you. Please, whenever you're ready.
Yes, hello everyone. My name is Sílvia Leirião. I'm a water resources engineer at DHI, and I'm working on the Flood and Drought Management Tools project, specifically in the development of the basin planning application, which is what I will present to you now. So I will start by introducing the project and the objectives, and then move on to the concept of the basin planning application, and finalize the presentation with some words on where we are right now and what are the next steps. So the Floods and Droughts Management Tools project aims at facilitating a scientific approach to decision-making by providing access to a number of applications. These applications are to be used at basin and local level, and one can also read at national and international level. These applications are designed to allow users to consider flood and drought issues into their planning processes. It's being implemented by UNEP, executed by IWA and DHI. The project targets operational planning decisions and strategic planning decisions, and that's why you now see these two pictures there to try to illustrate the difference. We are basically talking about short-term versus long-term. In operational planning, considerations are made with regards to seasonal variability and water management. So climate variability and water demands are factors. In strategic planning, we deal with investments that have a considerable project timescale or time horizon. And climate change and population growth become factors. This is a screenshot of the Flood and Drought portal. You can see the address at the bottom in blue there. So the Floods and Droughts project is developing a basin planning application, which I have highlighted there in the blue box. It's web-based, and it will be inserted into the portal. It'll be license-free, and it's located on the web server, so that there's no need for a local dongle. So if we look into this basin planning application, first of all, users are going to be stakeholders from different sectors. For example, water resources management at different levels and water utilities. And the objective is straightforward. It's to evaluate existing plans, create new plans, and evaluate them. And this brings us to clearly define what is a plan within our working context. A plan is a combination of investments and factors, and these are thought up to be sufficiently flexible to handle plans targeting different sectors and to be relevant in different locations around the globe. Plans are implemented in the basin planning application by adding features and information to an existing water resources model. So the basin planning application works with a model, and I started by saying that the target users are stakeholders, they are decision makers or technical staff, and they do not need to have specific knowledge of this underlying model. So it's been designed so that this water resources model is in the background. A plan is then evaluated by executing the water resources model and calculating indicators. And in this flowchart here, I'm kind of summarizing what I have just said. So first, there will be a stage of identifying the issues and objectives. There will be a definition of and design of plans. And then with the water resources model, we calculate indicators. The user also specifies different strategies which are used to evaluate the different plans and then will lead or support the decision. Continuing with explaining the concept of this basin planning application. The planning process is based on a baseline model where different plans are alterations of a baseline case. So in this image that you see there, I'm illustrating a typical water resources model. So our natural system and the coexisting anthropogenic components are schematized in the model, and their interactions are described and then simulated. The key components are the water sources and the consumptions and demands within the basin. So in this picture here, you can see we have the labeled objects of the model, the labeled components are catchments, water users, and these can be used to represent domestic, industrial, or agricultural consumptions. We have surface water reservoirs, groundwater storages, and hydropower schemes. And then we have our network, where every node is connected to each other, and this establishes the members of the water balance equations that get solved at every time step during the simulation period. So in our basin planning application concept, the investments equate with model components. And so a water resources model takes part in the evaluation of a plan by providing a measure of its impacts. Let us further describe the process with this chart here. So the user uploads the baseline model to the basin planning application, which is, as I've mentioned, located on the web server, and this baseline model will all be located and executed on the server. So there is no need for a model software installation locally. So the user does the upload, and then a baseline plan is established by the tool, and new plans created are going to incur in alterations to this baseline model. A user can choose to add, see in this gray box there, any of those types of investments, so water supply, irrigation, hydropower, and combine them with a climate change scenario or a population growth scenario. And so through the basin planning tool, after making these choices, this will be translated into modified values of water demand and a modified representation of climate conditions. And at the end, we will apply two types of analysis. We aim at applying CBA cost-benefit analysis and multiple criteria analysis. if we break up the green box of the previous slide for the evaluation, planning results will be based on indicators which are selected by the user. The user also specifies critical values that can be chosen and set by the user, as well as strategies. And the strategy is consists of a prioritization between indicators and aiming at different strategic goals and policy targets. And so the CBA can be used to make a comparative assessment of the benefits that are anticipated and the costs, and the multiple criteria analysis where different plans are evaluated against different strategies. And this will culminate in supporting the decision process. A few words on the workflow of the new basin planning application. The workflow is designed to have 3 flows. There's the results line where the user can view planning results and compare plans. There's the reporting line where the user can produce reports that describe the output. And this again, it can target non-technical users and decision makers. And finally, there's the third line, which is the planning, and here the user defines new plans. A more detailed view, firstly, the user can select from a list of available plans and view the planning results and also a comparison. So a user can basically view results, and if there is no need to create a new plan.
2 minutes, please, Silvia.
Okay. Then there's a huge focus on reporting, so that there will be different templates that the user can choose. And then there's the planning side of the basin application, where the user can select a baseline case, define new investments, and execute the plan. So I'll use these last 2 minutes to show you this mock-up of what we believe or are hoping the tool will look like. Basically, it follows the same style of the Floods and Droughts portal, with different options and dialogues centered around the main graphical display. And there you will see maps, charts, and tables presenting results. And a word on how the web interface is going to work in a different multiple user context. So the baseline models and the planning results are shared within a user group. You see there user 1, user 2, user 3. And a user group is a collection of registered users. And this user registration is implemented at the Floods and Droughts portal level. So multiple users can access different baseline cases and results, and each of these corresponds to a certain user group. And the information transferred between the web server and the user are basically, we have thought it up to be very light information so that the web solution works even with poor internet connectivity. And so the information transferred is purely what is needed to evaluate plans, create plans, and disseminate the planning results. And this brings me to the end of the presentation. We basically saw how the basin planning application is inserted in the context of the Floods and Droughts project. We viewed the main objectives and the concept, as well as the key components of the workflow that this basin planning tool will have. And now, just to provide an indication of where we are, we expect to have a release by September this year, but there's still further work required, particularly on indicators. There will be training and testing with stakeholders, and also some further development to support the WEEP model. And this is the end of the presentation. We're very excited about this new application and look forward to seeing it used and applied. And that is all. Thank you for your attention.
And thank you, Sylvia. Please don't run away just yet, though, because we have some questions. While Maija just hands over the presentation rights to me. Thank you, Maija. And I get things up and running here. I'd like to ask people to submit questions for Sylvia as well, if you haven't already done so. I'd also like to ask Børge to reopen his microphone so he can respond to a few of the questions. But the first one is for Sylvia. Sylvia, you mentioned application. I understand that this is not a kind of mobile phone app, or is mobile phone app capability part of thinking?
No, it's inserted in the Floods and Droughts portal.
Right, that's good, and it's great that you're keeping your answers short and sweet as well, because we got a lot of good questions here. Which model is it that you're using, please, Sylvia?
Well, right now we are developing I can also refer to it as basin planning tool instead of application, if that leads to any confusion. The tool supports currently the Shire Basin software. It will support the WEEP software. In terms of type of models, the model is a network model, a basin model where you can have rainfall runoff modeling, and you may or may not have groundwater.
And it's good you mentioned groundwater, because a very quick question for you is, what is the importance given to groundwater in this model?
Well, it's very important because depending on the basin, and bear in mind that the idea is that this can be applied to different basins around the world, and groundwater in different cases can be a very important source for water supply to different uses, so domestic or irrigation. So there is, it can support a model that has a groundwater reservoir being simulated, and then a certain percentage of a demand can be sourced from groundwater.
Many thanks,
so I would say
Sylvia.
it's quite important, yeah.
Yeah, thank you. Børge, are you there?
Yes.
Right, great. A quick couple of questions for you. Sylvia, please don't run away. You have a chance to catch your breath, though. Børge, can the tool be used in monitoring the basin management plan once an investment plan has been decided?
Yes, of course. I would say.
Okay, that's the whole.
Yeah. So when an investment plan has been decided, then you can implement that in the model, and then you can rerun the model. You can actually make that part of a planning option, and then you can see what is the change. What is the change in basin score or in indicators?
Okay, that sounds interesting. Next question also for you. Since the Shire is a transboundary basin, Malawi and Mozambique, I'm reading directly here, were both countries participating in the basin planning exercise?
This is, well, I don't think they were, but I'm not the right to answer this, but I think Mozambique has not been involved in developing the basin plan. I don't know whether there has been any contacts during that I have to ask the team leader of.
Right, just to elaborate a little on the response there so it's clear, if you allow me. Børge, my understanding is that you've been an expert in a certain part of the project, and of course you're not expert in all of the project, and so that transboundary dialogue and whether to take that on board was not part of your mandate in the project, right?
Yes, that's right.
Right. Silvia, a question for you. If I upload a model I have, will it be made public?
No. So the way it works is that it works with user groups. So users that are inside the same group have access to the planning results. This is designed for decision makers who do not need a specific knowledge of this model. So there is no interaction with the model. Anyways, in any case, but your model, its results, and specifically what is displayed, which are the planning results, this is only shared within the user group, which are the people who have been accepted by a user group administrator to be able to visualize this specific basin case.
Thanks for that, Silvia. Good, clear response. A last question for Børge. Are you there?
Yes.
I think you're getting all the tricky ones. How were the vision or key areas incorporated into the planning process? The connection wasn't completely clear for me. That's one question.
Yes. Maybe, I don't know if I need to open the PowerPoint presentation again.
We're a little pressed for time, so
okay.
it would be great.
What I should say that for each of the key areas on the vision, the prosperous families or the green catchments and so on, there are, for instance, in terms of the sector, for each sector there are sector goals that support this vision. So there is for the agricultural, there is for the fisheries and so on. There are sector goals that should then support the vision of getting more wealthier families. And the same thing with the green catchments. There's sector goals within forestry and so on to improve the visions of green catchments and so on.
Many thanks for that response, Børge. I'm afraid that's all we have time for in terms of questions right now, and any of your unanswered questions that you've sent the presenters, we're going to be looking at them, asking them to respond to you directly, so please don't feel left out or too left out there. As mentioned, we're planning on getting the recording up on the website along with the others and the presentations within the next few days, so please keep an eye open for that. As mentioned, this is unfortunately the final webinar in the series, at least for the time being. The plan is to maybe come up with a new webinar series on floods and droughts. So if you have any thoughts on that, we'd like to hear that. I'll come back to that briefly in a second in terms of feedback. But in the meantime, I'd just like to make a quick advert for our brand new series, webinar series, which is on source to sea management. And in this webinar series, we're covering kind of the typical ridge to reef issues in terms of the Sustainable Development Goals 6 and 14 and how they can be managed. And I've included a link here on where you can find some more information on that. And we're always looking to improve the quality of our work, so if you could use a couple of minutes to fill in that feedback form you're going to be getting from us. As you automatically close this, you can include in there your thoughts and ideas on possible floods and droughts webinars for the future. Please allow me to conclude today's session by thanking the presenters for taking their time to share their knowledge with us. I'd also, of course, like to thank Maija for her help with setting things up and getting things done, and for Olaf from DHI in helping to organize the series and helping make sure everyone was in line and everything was up and running smoothly. I'd, of course, also like to thank you, the participants, for taking the time to join us and share your questions. I hope you found the series both fun and informative. Finally, let me please thank you very much once again and wish you all a very good morning, a good afternoon and good evening wherever you are. Bye for now.